Let's discuss today's problem. This is a very good problem, which is based on prefix sums and suffix sums. This is a Div 3 problem, which is rating 1900 on Code Forces. So I'll discuss again because the recording again got corrupted. I don't know how. So so we are given an array, which is like this. Suppose so the numbers are written like this. So here the main part is that you know the answer in this problem, you know how to do it, but there are a lot of what we call that edge cases are there. So it becomes a tricky problem. That's why this is in 1900. Else it would have been in 1400 or 1300. So main problem about this problem is that this is a tricky problem in order to handle the edge cases. So I'm going to tell you how to handle. So in this problem, the author has chosen certain dates, and in each date there will be only one examination, and the date will be till D. So okay, so there would be no clashing between any two examinations, as the author says. So that's fine, but that should not trouble us because what we want to find is that maximum gap, minimum gap, which we have to keep. So this is gap one, this is gap two, this is gap three. So the author wants us to maximize the minimum gap. So the minimum gap in which the author takes an examination should be maximized. So how to proceed? And in order to do that, he wants us to manipulate only one element. So only one examination, at most one examination you can manipulate. So the answer is always a zero because you can always place adjacent to them. Then that's not a case big deal. So also we should not get panicked about the examination being held on the similar day, because if we keep them on the similar day also by greedy method, it would be not it would always give us minimum not good answer, because answer would be zero in that case. So even if we accidentally put some examination on the same day, it will not give us a wrong it will not give us it will give us a wrong value, but we should handle that case also. So so this is the scenario of the question, and this is what author wants us from. Let's start from four prefix arrays, which we will have four types of array in short. So there will be four types of array. So one is prefix, which is minimum prefix. That's called as mini prefix, maximum prefix, maximum. Okay, so I fucked up again. So mini suffix, maxi suffix. So this is now again there is a very good observation here. So what is a mini suffix array? So mini suffix array is an array which stores minimum gap which is created till now. So that is what minimum array. So I'll draw each array separately because the chances of getting a wrong answer is very high. So this is a day one, and this is certain date x. So the gap between them is this 2. So the answer for this will be previous minus current. Sorry. Current minus previous, because that will give us a negative value. So x minus previous minus 1 will be in general case if there is some element placed. But if there is no element, suppose we don't have any element because it is the first day and there is no examination on that day. So in that case we don't have a previous element, so I is equal to 0 in that case. So that will be x minus 1, simply because we have this much of gap. So this should be very clear about prefix, minimum prefix and maximum prefix that we want to create like this. If I is equal to 0, then x minus 1, else x minus previous minus 1. And we take maximum of previous if it exists, so we take maximum. So now regarding minimum suffix and maximum suffix, what we do here is it is again a tricky thing, because let's discuss that also. Suppose this is d, this is suppose I don't want to take d, let's take 6 5 4 3 2 and 1, and discard this does not exist. So 6. So suppose I keep an exam here. So what will be the answer for this? Nothing, because this is not a gap, right? So right hand side is not a gap. If there was an exam here, then it would be counted as a gap, but it is not a gap. So the gap should be, so for I is equal to n minus 1, minimum should be maximum, and maximum should be minimum of mini suffix of n minus 1, and maximum suffix of n minus 1 should be minimum and maximum respectively. So that's one point. And if else we do like the same way. Suppose there was an examination here also, though we write x minus y minus 1 as this current gap, and we take maximum and minimum correspondingly from the previous gaps which we were having. So that's the scenario of minimum and maximum. Okay, so that's nice. So now let's go to the cases here very quickly. So the answer will be I is equal to 0, I less than n, I plus plus. Everyone knows this, because because we are very clear about this problem, that this problem is easy but edge cases are hard. So let's, if I is equal to 0, then there would be some case, I don't know, else if I is equal to n minus 1, there would be some other case, else it will be some other case. Suppose I equal to 0, so we have to erase that zeroth element. Zeroth first, we have to erase the first examination which was held. So the second examination here is important, because the author is very good. So he gave us two elements at least, because if there was only one element, we would have kept at D. That was an edge case. But again, the author is very kind to us, so he gave us two elements to work with. So that's nice. Thank you, author sir. So what we can do is, we can just make things. We can, what we have now. We have minimum, what the minimum value which we can achieve, what is the minimum value. So I write is that minimum m equal to minimum of suffix, because there is no point of taking prefix, comma, array of 1 minus 1. This is the total minimum value which we can achieve. So that's what I have written here. Yeah, this is the minimum value which we can achieve. Okay, so this is and everything here will be a minimum value which we can achieve. Out of that minimum, we have to achieve a good value. So I will be explaining this m also and this m also. So for regarding this m, we have to erase the last element. So what are the minimum values which we have? So this is very nice, very good prefix of minimum. Minimum prefix of n minus 2 we have to take. Minimum of prefix of n minus 2. We should take this, because if we don't take this, then that will be a problem. So that's nice. And this will take minimum of certain things. Minimum of min prefix of, I'll write in short, n minus I minus 1. Writing with mouse is a next level task. Uh, Comma max, comma again, that is min of suffix of I plus 1, comma array of I plus 1 minus array of I minus 1 minus 1. Here I made a mistake and got a wrong answer because I didn't put minus 1. So this is the gap which is created after erasing ith element. Regarding this, so now the answer is equal to, so we put, and what is get, suppose the gap is g, so suppose the gap is g, suppose the gap is 2, so what we can place is 0 answer, because the gap is 2. Suppose there is an element here, there is an element here, and we have 2. We, even if we put here, then answer will be 0. Even if we put here, the answer will be 0, because here there exists an element. So that's very obvious. So answer would be, if x mod 2 is g mod 2 is equal to 0, then g divided by 2 minus 1, else g divided by 2. Simple. So this is the get function, which is kind of seal, you can say, but that's not the correct term. So this is, the answer would be, this is the gap between the first element for second test and 1, so that we can take, and this is between the last. So suppose I place an examination on the last date, so what would be the gap? Array of n minus 1 minus d minus 1, because, so d is now d, there is, I place something on d, so minus 1, and you should not take care of condition that if there is an examination already on that day, even if there is an examination that will give us a minus 1, something like that answer, and the answer would always be greater than equal to 0, so we don't have to take attention about that test cases, about that edge cases, so we just directly put that thing. And also you can place maximum which you can afford, divided by get of that maximum, which uh, which which will be carried out using maximum suffix of 1. Similarly, but carefully we calculate, they almost same, but here there is an edge case here there. So again I just forgot to put minus 1, that's why I got, this gap is very important. To correct gap, mentioning correct gap is important. So this we, we can take maximum value of prefix, maximum suffix, maximum the current, or we can place it on the front side or last side. It's your choice. So this is the problem. That's it. So these are the conditions that are very troubling to us, but at last we conquered them using some basic logic and writing test cases. So thank you for watching and listening. Bye bye.